Okay, next. So the life cycle methodology. So in this case, we are talking about the cradle to grave. So which is the approach to evaluate the products, the material, processes, service, and the with respect to their environmental impact, which is in the Hanover principles, principle number 6. So the cradle to grave, it process begin the extracting the new material from the earth, and ends at the point where all materials are returned back to the earth in some of other forms. So basically, LCA studies, it helps the decision maker to select which process that is the least evil in terms of the impact on the environment footprint. However, this is important. The final judgment and the interpretations of the result is always depend on the set key metrics that you set. In that sense, the LCA objective, it should be set earlier in the analysis. I mean, this is in the preparation to answer the questions relevant to the projects or the applications. The normal or classic LCA usually is done on the environmental impacts, but the advanced, it can be used for the another informations like the cost and also the performance data, which is to find the optimal solutions. Okay, next. So this diagram, so basically you can see that any product or the technology, it would require the input to some raw materials and energy at one stage, at all the stages. You start from the acquisitions and to the manufacturings, operations, and finally at the disposals. All of the mentioned life cycle stages, basically it can produce the atmospheric emissions, the waterborne, and also the solid waste. Because the efficiency of the material use and also the energy conversion is not always 100%. So this diagram basically is a based around a it's a box shape system that includes the 4 processes and is surrounded by a system boundary. You can see the highlighted 4 stages as the raw material acquisitions, the manufacturings, the operations, use, maintenance, recycle, waste management. So the system inputs is shown as arrows on the left outside the system boundary. So the inputs usually is represented by the raw materials and the energy that flows into the systems. The system output is shown as an arrow on the right side and at the bottom of the system, which is outside the system boundary. Outputs is always represented by the main product and the co-products shown at the bottom, and the atmospheric emissions, waterborne waste, and also the solid waste, which is shown on the right side. Okay, next. So the procedures to the life cycle assessments. So the LCA, it should be include the several key steps as below, like what is your goal definition and scopes? You need to find the product, system properties, LCA map, etc. What is your inventory analysis? You need to collect data, identify the quality, and quantify the energies and so on. What is and do the impact assessments? So which is to set the impact categories, the development phase, the calculations, and also the comparative analysis, and also the interpretations of the assessments, which is relate back to your metrics. Okay, next. And what is the limitations here? So of course, the LCA thoroughness and the accuracy will depend on the available data. And this data is rather scarce this time because this is relatively new. So in this case, to gather the data, it can be very problematic. So that's why a clear understanding of the uncertainty and the assumption is very important. So the classic LCA, it will not determine of which product, processor, technology is the most cost-effective or top-performing. So that's why the normal LCA, the classic LCA, it need to be combined with the cost analysis, of course, with the technical evaluations and another social metrics, in order to be comprehensively to become like a sustainability analysis. So they unlike the risk as the traditional risk LCA, it doesn't attempt to quantify the specific impact, actual impacts. So usually this is LCA is suitable for the relative comparisons, but it may be not sufficient for the absolute predictions of the risk. So even for the relatively small system, so LCA actually we can say it's a comprehensive task that require the interdisciplinary knowledge of the technical and also the economic areas. So that's why the LCA projects usually is assigned to a team of experts, and it rarely can be performed by a single person with certain sufficient accuracy. Even though the LCA approach has been developed over the decades, so coming from the product-oriented models used to evaluate the environmental impact, even to a bigger framework that elaborates on the wider environmentals, economics, and also the social scales. So at this stage, LCA is being transformed into the life cycle sustainability analysis, LCSA, of which links the sustainability questions with the knowledge and the research needed to address them. Okay, next. All right, so basically in part 2, we already explored the definition of technologies. We already go for the TRL requirement on the analysis, and also we already go for the some of the background on both the evaluation methodologies. So the next step, we're going to look into how to choose the correct metrics and how to develop the quantitative indicators for the assessments. All right, so now we go for the part 3 of these sessions. All right, so this part, basically we are looking into the evaluations of the technologies from the standpoint of the environments, economics, and also the social compatibility. So I think we can start next. So basically by end of this part 3, we can be ready for the real application of this. So here we're going to understand what is the different levels of metrics and how their connections with our assessment goals. Some calculations on the environmental metrics and the indicators and how we interpret the meanings of the calculations. And also we're going to review the fundamentals of the economic analysis of the technologies. Of course, some calculations on the economic metrics. This is using the simple paybacks and also the discounted cash flow approach. All right, next. So this is some of the references. You can use it later. All right, next. So when we are asked this question, is this process sustainable? So usually we cannot get the answer, a solid answer, yes, no. So some of the parts of the system, it may be benefit the sustainable development. Some of the parts, it can be in conflict with it. And some part may be rather neutral or it can be very flexible. But how we can tell that where we are on the scale of the sustainability assessments? Furthermore, for example, let's say if we alter the certain parts of the system, how much shift or impact that we give toward the sustainability goals, and how we want to measure the impact of those changes. This is a question that prompts the attempt to develop a quantifiable metrics. The word is quantifiable metrics, or the indicators, of which it can allow the researchers and the policymakers to make some accurate comparisons between the different paths of the system development, and of course, to make the justified decisions. The existing methods for evaluating the products and technologies in terms of environmental impact, actually there's a lot. The metrics has been or continue to be developed by different agencies, companies, researchers to address a variety of issues. So as a result, those methods maybe is widely diverging rationale. terminology, approach, and also it come up with a contrasting result. So the challenges here is the consistency and also the compatibility is the most difficult issues. So in this lesson, basically it would be hard to possibly tell that all the method in detail. I mean, because some of the model actually is a subject specific, but I try to make it. But we're going to take a tour, of course, and then I try to touch a little bit on each of the methods. And of course, there's a numerous technology existing in the world, which differ in the many aspects, like profitability, like the social popularity, like the efficiency, scale, local need, resource consumptions, for example. However, our main goal will be is to distinguish and to characterize the technologies in terms of the sustainable development, of which in the long run, the main questions that we like to answer is this technology project sustainable or not sustainable? And what is the good, what is the criteria for the good and the evil aspects here? Okay, next. So how this is being, how this matrix is developed. So according to the Warner and Sauder, the choice of the appropriate measurement metric depends on the user's needs and purpose, the key of study, and the available data. Setting the purpose of evaluations is the key. Without it, the metrics are simply data. There should be a decision focus. Okay, next. So basically, the metrics should help answer our questions, and the answer in turn would justify the recommendations for future actions. So in this case, we can categorize the metrics into a quantitative, subjective, qualitative, or it can be the integrated metrics. So this type of often determined by the availability or the accuracy of the raw data. And the data, it must be accessible and affordable, because otherwise the assumptions and the surrogate information, it will undermine the adequacy and the validity of the assessments. The standardizations and also the coherence in the rules and the constructions of technology evaluation metrics. I mean, this is not yet achieved. I mean, in the broad area of the science and technology, the practice of creating and using metrics, actually we are, I mean, even in our organizations also, is still like a select menu, I would say. So means that is try to suit the certain goal. This is the where the evaluators will select the accommodations measures, data source, instrument. So in this case, basically, it's only to address the specific objective and needs. Okay, next. So actually, this is the issues that make the matrix is not a straightforward meta. So basically, the matrix, it can be composed a single quantity or more complex set of measures. Metrics in science technology evaluation are designed to measure a variety of activities like events, phenomena. Some is simple, short-lived, some is complex. And also there's an absence of a unique and a single building block, which is increase the role of subjective reasons. So to design a comprehensive universal matrix, so this is what we call it, would work like a magic crystals. I mean, for the decision makers, it's difficult, if at all possible, I would say, because different stakeholders, they care about the different impacts. Most analytical approach separate context and they rather develop the multi-metrics frameworks for assessments. All right, so I think we can see more clearly on the next table. All right, next. So this is actually some of the examples of the informative metrics that we can use for the socials, environmentals, and also the economics. All right, next. Now we go for the lagging versus leading metrics. So lagging metrics basically is those that indicate what is already happened, like how much soil is already eroded, and how much cost of the electricity. Leading metrics basically is those that indicate what will happen in the future, like at current rate, how much will be the deforestation rate in the future? What is the will be the input-output ratios, or for example, like wind direction and speed. So the lagging metrics actually is mainly actual measurements. Leading metrics usually is indicators of the market rates, or we can name it as a trend. All right, next. So this is the complexity levels of metrics. So there are 5 levels of the complexity. So in the above hierarchy, level 1, level 2, it may be sufficient for the understanding the promise of the technical performance, because this level usually is a primary guide in the relationships between the research and the development sector and also the industry, of which look for, of course, look for reliable and the efficiency system. The ecological perspective, usually it would involve level 3 in order to understand and track the environmental impacts. I mean, furthermore, if you look into the sustainability analysis, they would have to involve the level 4 at the community scales and level 5 at the economy scales. Since this is only through the life cycle assessments and the system analysis is possible to identify the correct targets for the metric designs. So one of the ways to understand if the choice of metrics that is adequate for the purpose is through the sensitivity analysis. By varying impact factors, I mean, to see how the matrix is responding, to simulate a series of what if and what if not scenario basically will lead you to design a proper metric model and also to define the boundaries of your projects. Okay, next. So the sustainability indicators basically is a collections of the data and the informations for calculating the sustainability indicators. Maybe it's a big task because much of the data can be available in local, state, federal government reports, and many other those can be online this day. But in some cases, you need to contact the respective agencies and office, to request for the missing informations. One of the criticism of the sustainability metrics and also the indicators is they try to encapsulate an array of diverse processes and the interactions into a simple measures. Here comes the question is whether that simplification is fair, and what will be the risk using that simplified measures for taking rational decisions. And in fact, to design a matrix, it can be an obvious approach to deal with the complex world. In a manageable bits. So it's a common for researcher, scientists to deal with a complex system by breaking it down and studying its components separately before we study how it works together. For examples, in the natural worlds, in natural science, scientists has been dealing with a complex ecosystem for years, and specific indicators may be used as a tool for gauging ecosystem health and development. All right, next. So this is the indicators. So according to Slobod Kit, so simplifications limits our capacity to draw conclusions, but this is by no means unique to ecology. Essentially, all science is the study of either very small bits of reality or simplified surrogates of complex whole system. How we simplify can be critical. Careless simplifications, basically, it leads to misleading simplistic conclusions. Okay, next. So basically, environmental impacts is to design to assess the environmental impact on the technology and also the activities. So the goal basically is to minimize the impact on the environmental due to the non-renewable resources and also to minimize waste and the pollutions. Next. So this is basically is the metrics that related to the life cycle input. So we can say like the water use, the land use, the embodied energy, and also the total life cycle energy. Okay, next. This is another matrix related to the life cycle outputs. So here we are talking about the global warming potentials, the ozone depletion potentials, the water soil acidification potentials, and etc. Okay, next. Imagery and the transformity. So the concept of the imagery and the transformity basically is introduced as a universal measures in the environmental accounting theory. So this approach basically is to use energy unit to assess the input and the output of the various resource in the industrial systems. Okay, next. So the transformity, for example, during a hot day, we can use the air conditioner. So the energy to power the air conditioner basically is come from the electricity grid. So prior to that, the electric energy is generated at a power plant through the conversion of the thermal energy of steams. This is steam turbine and it goes to your steam generator. And the thermal energy actually is in turn is produced by the combustions of the fossil fuels. So the energy stored in the fossil fuels actually is coming through the plants through a photosynthesis. So we can say that the solar energy is indeed the original component of the final energy used in the air conditioner. So this is the transformity basically is a change of state of energy from the source, which is the sun, toward the final form. All right, next. So energy basically is defined as the available solar energy used up directly or indirectly to make a service, product, fuel, or another form of usable resource. So the term will be used as the energy equal to solar energy joule, equivalent to the energy stored or available in joule. And what is the transformity? Solar energy joule per joule. All right, next. So this is actually the examples of the transformity calculations. So we are talking about the transformity is how much is the solar energy flow over the overall energy flow. So for example, this is a calculation for 1 gig of forest. So basically the solar energy flows essentially indicate how much solar energy is supplied by the sun into that 1 gigahectare of areas. So this is, of course, it depends on the installations of each, it depends on the geographic locations, where the local weather profile and etc. Okay, next. Another method is the embodied energy. So embodied energy basically is the sum of all the energy required to produce any material or product, considered that the energy is incorporated or embodied in the product itself. Okay, next. So for example, in this case from Hammond and Jones, so in a concrete, for example, per kilo, there's a 1.1 megajoule of energy stored per kilogram of concrete, for example. So for a more complex product, for example, like using the multiple raw materials, so the embodied energy basically is increased significantly. For example, like the one used in our solar panel, the monocrystalline silicon. So the embodied energy basically is estimated around 4,750 megajoule per meter cube. Okay, next. This is another matrix which is common to account for the greenhouse emissions of our projects. So this technique, the global warming potential, it can be used within the life cycle assessment and also outside of the criterion for choosing the most climate-friendly solutions among the alternatives. So this is always related to the carbon dioxide as a universal benchmark. So GWP is always depend on the infrared radiation's absorption properties, and also the spectral location of the absorbed wavelengths, and what is the atmospheric lifetime. Okay, next. So for example, for a methane gas is rated as 25. So it means that methane molecules, it costs 25 times more warming as a single CO2 molecules because due to its stronger greenhouse effects. So below it basically is the examples of the pollutants graded on the GWP scales. Okay, next. So this is the examples on the calculation on the global warming potentials. So from the agriculture projects, so it's estimated like, for example, 5 tons per year of the gas of CO2 from the gasolines, 0.1 ton per year from methane, and also 0.01 ton per year from the nitrous oxides. So in combinations, the global warming potential is equivalent to 10.48 ton of the carbon dioxide equivalent. Okay, next. So basically the economic metrics, the main questions that we like to answer is whether the process or the technology is cost effective, whether the deployment of the project is financially viable, and what will be the cost of the products and the services to the public. All right. So to analyze the economic metrics, there are two methods. One of it now is the cash flow analysis. All right. Next. So cash flow analysis actually is a tool to use how the project expenses and the revenues vary over the term of the projects. So it's a financial timeline. So for the basic cash flow, so this is the following, the following terms it needs to be defined, like the term of the projects, what is your initial cost or your capital investments, and what is your annuity, and also what is your salvage value. All right, next. So in order for us to evaluate, so the initials and also the revenues, so in order for it, so we want to maintain the cash flows analysis as positive as possible. Only then it's considered as a viable. Okay, next. So this another one is the call as a simple payback approach, which is the net present value. So the net present values is equivalent to your initial cost plus your annuities and also your salvage values. So if your NPV is positive, net present values, then the project is considered as financially stable, viable. All right, next. So this is an example. If you start with the initial cost of 100,000 and the annuity is 20,000 for the next 20 years, and the salvage value of the project is 5,000. So at the end of the lifetime, basically it will be valued as 105,000. So basically this positive NPV indicates that this project is financially viable. Okay, next. The simple payback approach, which is called as a break-even point. So this is to indicate the number of years after of which the initial expenditures is going to pay back. So it's equivalent like the return of investments. Like next. For examples, like just now. So you have the NPV of 105,000. So your initial investment is 100,000 and your annuity is 20,000. So is divided, then it's equivalent to 5 years. So means that your project will pay back by itself within 5 years. All right, next. So this is the capital recovery factors. CRF is equivalent to ACC and also divided by NPV. So in this case, the CRF factor, it shouldn't be go high for a project because to be considered as financially viable. So in this case, if you look from the recommendations from the electric power research, The CRF value it shouldn't exceed 12% in this case. But of course, this figure basically is the metrics which is determined by you during the start of the projects. Okay, next. Considering the same example just now, so we can say that our ACC is 9,000. Then from this figure, we can say our CRF value will be at 9%, which is lower than 12%. So in this case, is viable, I would say, according to the electric power research. Next. Another method, basically, we call it a discounted cash flow analysis, which is also the, in this case, the NPV value is including of the initial cost plus the P over A, annuity, and also the salvage value. Okay, next. Okay, taking it from the example just now. So let's say if the initial investment set is 5%, the conversion factor for the 10 years it can be calculated as this one. So even though we include the depreciation stake, so the NPV of this project is still positive. So it means that indicate it's economic viable again. Okay, next. So another metric that we can use is called as the internal rate of return, IRR, which is actually correspondent to the marginal interest rate that would allow the project to break even at the end of the term. Okay, next. So this is actually the other terms that you can use also in your evaluations for the economic measures. So now we're going to go for the last part, which is the social metrics. Okay, next. So according to the Western Australia Councils of Social Service, so social sustainability occurs when the formal and the informal processes, systems, structures, and the relationship actively support the capacity of current and future generations to create healthy and livable communities. The socially sustainable communities are equitable, diverse, connected, and democratic, provide a good quality of life. Okay, next. So this is the dimensions in the social context. So here we are looking for the quality of life. Basically, is the basic need are met and a good quality of life for all members is fostered at the individual, group, and also the community level. So basically, in evaluating your projects, you can use, the below questions whether how the development affects or improves. Okay, next. Another dimensions in the social context is the equity. The equity here is referring to the equitable opportunities and the outcomes for all its members, particularly the poorest and the most vulnerable members in the community. Of course, you need to check how your technology project will this gift reduce the disadvantages for the target group and etc. Okay, next. And also the diversity. The diversity here is reference to the coexistence of the different points, practices, ethnic, cultural, racial groups in the community. So basically, in this case, you need to mention how the technology project it will impact the diverse group in your the diverse group within the target group and how a way to look for their particular needs. Okay, next. Interconnected and also the social cohesions. So this part basically is the establishment of the process, system, and the structures that promote connectedness within and outside the community at the formal, informal, and also at the institutional levels. So basically, this one basically is to see how your technology can help the group to develop the sense of belonging, within a broader communities. And how to increase the participations, actually, in a simpler word. Next. And the democracy and the governance, the ensuring the democratic processes and open and accountable governance structures. Next, maturity basically is the individual acceptance or the responsibility of consistent growth and the improvement through the broader social attributes. So in this case, the maturity is how the project can be dependent on the responsible decisions of the individual in the target groups. And this one basically it requires the additional knowledge and the educations from the stakeholders. All right, next. Sustainability index. So so it has been constructed by, in this case, Brown and Olgiati. So this is based on the imagery theory. So this diagram basically is showing the energy flows and the transformations also within the generic local, so which is surrounded by the box. The economic box, it can seen as a transformer, and it resolves into some yield, which is Y in this case, and the subproduct directly to the functions of the systems. So the inputs of the system is classified as the renewable resource, non-renewable resource, local resource, and also the non-local. So in this model, basically it's assumed that the local system sustainability is favored by using the renewable energy resource and the local energy resources. So the resources that are both renewable and local, they are denoted by the R in this diagram. The non-renewable is denoted by N, and also the non-local, which is the purchase resource, is denoted as F. Okay, next. So the environmental loading ratio, so is ELR is equivalent to the F, if you still remember the denotation just now, plus N divided by R. So we can see that the more non-renewable and outside resource are involved in the process, so the higher the ERL index will be. So as you can see that we want the ELR to be lower as possible, I'll say. Next, the energy yield ratio is characterized by the capability to exploit the local resources. So in this case, you can see that the higher the yield and also the increasing the F, so the lower and also the lower the EWR, and so the higher the system vulnerability will be. All right, next. Sustainability index is to combine the both ELR and the EWR as follow. So means that for the highest sustainability score, so we want to have the EWR more versus the lowest ELR. So we can say that through this one, the sustainability index, it can be used as the aggregate to measure characterize the sustainability function of a certain process, technology, and also the economic model. All right, next. And of course, as I mentioned in earlier stage, we want to have the balance between the economic, socials, and also the environment, economic, and also the social dimensions. So, but in the real life, so this one is hardly to be achieved because it's always gravitated into one of these three dimensions. So one of the aspects that we can use to evaluate of which of the dimensions they would like to improve, basically we can see from the next slide from the circles of sustainability. All right, next. So this figure basically is a presence on the example how the different categories of metrics basically they balance into the characterize of the sustainability profile. So from these presentations, we can see that we can immediately recognize the most problematic areas in the city. Basically, is the emissions and waste, and also the materials and energy flows. We can see also from this diagram, the most improved is the cultural engagement and identity. So we can also, from this matrix, we can conclude that the ecological part of this sustainable system is more suppressed, while the cultural part is probably the most developed and sound. Okay, next. So basically for the part 3, so we already go through the what is the idea expectations that's on the 3 evaluations domain, like the environmentals, the economics, and also the socials. So the scoring matrix, in this case, it should be chosen rightly with the primary considerations on the main stakeholders' interests. All right, I hope everyone is still with me. Now we're going to the applications from the BSF and Petronas views. So this is actually is the approach from the BSF chemical from the BSF groups. We call as the circular economy. So the target from the circular economy, basically, we want to speed up um, the transitions from the least sustainable into a sustainable approach through the circular economy programs. Okay, next. All right, so basically our purpose, we want to create the chemistry for a sustainable futures. So all of the projects and also the approach, you can download it from the QR codes later. So in this case, basically we are talking about what we want to achieve. All right, next slide. So basically we want to be thought and action leader in the area of the sustainability. And also we want to increase the role of sustainability in our business decisions, of course. And we want to show how we can add the value to the society along the value chains. The key measures that we use for this circular economy approach basically is to decouple our carbon dioxide emissions from organic growth through a carbon management program. So one of it basically is to speed up our transitions to a circular economy through a circular economy programs. And also we want to further increase our sales from accelerator products, which make a substantial sustainability contributions in the value chains. All right, next. So this is actually one of the photo from our BSF projects Resicen in Brazil. So as you can see that in this photo, I mean, this is one of our staff, which is also involved in the sustainability program. So 1 million of the 1 million tons of batteries from the electric vehicles, it will reach their end life in 2030. But you can see that only 18% of the global plastic waste is recycled. And over than 8 millions of tons of plastic waste is ended up in the oceans per annum. So how we want to go for the circular economy? Okay, next. So our stakeholders basically are already driving the transformations to a circular economy. So we are looking from the markets. So from the markets, basically the players already set the ambitious circular economy targets. The legislators, especially in the European Union, so there will be our levy effective in the journey to in January 2021. So basically, it's over than 800,000 euro, but over than 800 euro per ton for non-recycled plastic packaging waste. The investors, we are talking about the BlackRock Circular Economy Fund, has been raised 900 million only in the first year. So this is basically the target of BSF on the GDP growth scenario. So in the circular economy CAGR, we are targeting for 6%, whereas in the linear CAGR is about 0.2%. So in this case, we can say that the circular economy business model basically is grows significantly much stronger than the linear economies for the past years. Okay, next. So the circular economy basically aims to decouple the growth from the resource consumptions and actually is regenerative by designs. So you can think by you can imagine by rethink of the design and use the resources and as try to keep them as long as possible in the chain. This is basically done through the recover and also recycle the products and the materials. And of course, this to improve by avoiding waste and the pollutions, and this to in order to protect the natural systems. Let's take an example on the linear economy. Okay, next. So this is the example from the linear economy models. So basically, is take the natural resources, make it into a product, and deliver it to the markets. And when it reach to the market, then dispose and then dispose. So if you can see that the lifetime of the product is very short in the entire chain. So what we try to make basically is the circular economy. Okay, the next slide, please. Or in the circular economy, where basically we can reuse, and also we can recycle. So for examples, like for the natural resource that we have, it can be the fuel and the feedstocks to the processes. So through the processes, like for example, like pyrolysis, or we can do the remonerizations or depolymerizations, and also through the mechanical recyclings, through the remanufactures, or through the repair and reuse. Basically, we can keep the material as long as possible in the chain until it reaches certain limitations, of course. Whereas we can then it becomes like a waste collection sorting, then it goes back to the dump waste. So this is actually the intentions of the circular economy. We want to maintain the product as long as possible in the chain. And how we want to drive this circular economy. Next. So in BSF, basically we aim at doubling our circular sales to reach at least 17 billion by 2030 through the circular economy. So we have the commitment also to use 200,000 metric tons of the recycled feedstocks by 2025 globally. And now we are run a circular economy program to accelerate the transitions. Next. And how we want to achieve this is based on the two portfolio concepts. So what the portfolio is close the loops. So basically it's to enable the closing of the recycling loop, and they are based on the recycled stocks, or we extend the loops. Basically it's the product that perform the best with less. So thus it helps to decouple the growth from the material consumptions. Okay, next. Of course, by doing this, we are facing the challenges. So some of the challenges they thing basically is the collaborations. So we look for the cross value chains collaboration for our new partnerships to shift the mindsets from the take, make, dispose into a circular models. And of course, the biggest part will be what we are discussing now is the technological, is the development of the recycling techniques and to ensuring purity of the materials to be recycled, certification and the regulations, and the use of the accepted claims, the waste as a raw materials. So how to source the waste with the suitable quality, of course, the price and also the volume, and to how to overcome the regulatory challenges. And of course, the infrastructure itself, how to develop the suitable system for the end of life waste streams. Okay, next. Through the circular economic networks. So basically, this one will requires the dialogue and the partnerships with stakeholders. So we engage in the networks is to better understand the trends in the society as the drivers of our business. And also this is to help shape the measurements and the performance standards. And of course, is to partner for joint contributions to circular economy. So below example basically is some of the partnerships that we have with the Ellen MacArthur Foundations. And also we have partnerships with the World Business Council for Sustainable Development, for the global battery alliances especially for the electric vehicles, and also the alliances to end the plastic waste. Okay, next. So there are three models that we are going to look into here. So basically, it's a circular feedstocks, the new material cycles, and the new business models. So now we're going to the next one. The first one is the circular feedstocks. Okay, next. All right, next. So, okay, so circular feedstocks, basically we're going to the chem cycling. So this is actually, we call it as a biomass balance approach. So by using the alternative raw materials, basically we can manufacture the same products in a more sustainable way. So the biomass balance portfolio, basically this is derived from the biomass waste of the agricultural productions, crops, or food processing or residuals. And the dedicated biomass portfolios. So this is, we are looking for the sustainably sourced resource like the SPO, RSPO certified. And we go for the recycled feedstocks like the chem cyclings. So this is actually derived from the post-consumer plastic waste and tires. Okay, next. The chem cycling is a trademark of BSF, which is the complementary approach to the existing recycling methods. So in this case, basically we are focused on the plastic waste that is not recycled mechanically for technological, economic, or ecological reasons. So this is, for examples, like the unclean plastics, which is used for the food containers, for example, and the plastics like with the special material compositions, in the one they use in automotive, or the mixed waste fractions, so which is consisting of the various plastics type. So also, which is not also sorted further because of the economic reasons, and of course the used tires. So we can say that the overall recycling rate of the plastic waste can be increased, and through that increase, so a more circular economy will be established. Okay, next. So basically, in this case, in the circle of the chem cycling projects. So in this case, the consumer use and dispose the plastic products or their tires, and then the waste companies will collect and sort the plastic waste and supply the BSF technology partners with it. Then this is the chemical element of it, the process element, the technology element of it. So our partners basically convert the plastic waste into a pyrolysis oil through a thermochemical process. Then the pyrolysis oil is purified to be used as the feedstock at the beginning of the BSF verbund productions. Verbund here is a German word stand for integrated integrations. So BSF then can allocate the recycled feedstocks to all the chemicals produced in this verbund via a certified mass balance approach. And then our customer then use this chemical to make their own product. So basically, the intermediates product from BSF, then it can be used as an intermediate in our customers to make their own products. And then this cycle will keeps going and going. So this is actually the intention is to retain the material as long as possible in the cycles. Okay, next. And why chem cycling actually is attractive in terms of the carbon dioxide emissions. So the result from the external, the critically reviewed life cycle assessment of the chem cycling. So basically is found that the pyrolysis of the mixed plastic waste is emit 50% less carbon dioxide than the incinerations of the mixed plastic waste. And the manufacturing of the plastic waste through the chemical recycling, so in this term is pyrolysis, or the mechanical recycling of mixed. So this is the result of the CO2 emission is comparables. So in this case, basically is we already taken into account that the quality of the chemical recycled product is equivalent to the virgin materials. And usually that once the less input material is sorted out, then with mechanical recyclings. Okay, next. So BSF biomass balance approach, well, basically it requires no reformulations because the identical product, because it's technically is an identical product performance. It's also easily available and fast for all, and also for nearly all our products. And of course, it saves the fossil fuels and also reduce the greenhouse gas emissions. And this approach also will drive the use of the sustainable renewable feedstocks. So on the bottom, actually, if you want to know about the biomass balance approach, so actually it's a methodology for the integrating the biomass balance approach into the LCA with the applications in the chemical sectors. Okay, next. So the biomass balance approach, so how we do it in our production sites. So the feedstocks from the steam crackers, so it goes in, either it's a fossil base or it's a renewable base. Then it goes into the utilizations of the so we use the current production movement for all the steps. And the products will be, it can be the conventional products, and also it can be the biomass balance product. So technically, if you see from this page, either we use the fossil, I mean the non-renewable or virgin products or virgin feeds, I'll say, based on the renewable feeds. So technically, we are producing the same quality of the final products. And this approach basically will not change much in terms of the processes. So that's why the integration cost will be lesser. Okay, next. So so now basically the raw material for the biomass, it need to be sourced sustainably. So in this case, we are using the certified renewable raw materials, and this is, and also the independent sustainability certification is available from the recognized scheme, right? In this case is the red certs. And also to apply the standardized sustainability criteria. So this is according to the minimum sustainability criteria as in the European Union renewable energy directives. And we go for the green gas emission savings, responsible biomass productions, and also the protection of areas with the high biodiversity and the large carbon stocks. All right, so the next one, we're going to go for the new material cycles. Examples on the closed loops. All right, closed loops. This is one of our products. We trademark it as Petra. So Petra grades basically is grade based on the 100% post-consumer polyethylene polyethylene products bottles. So the performance advantage basically is through the high temperature performance, the chemical resistance, the good electrical properties, and the ease of course, it's the ease of processing. So mostly this product is used in the applications in the electrical connectors, like your cable insulators and so on, and also the power tools for the motor components and also the housings, and also the application handles because it can withstand a high temperature. Okay, next. So this is examples of the extend the loops. So this is one of two products. This is Luprosil and also the Amasil. So this is basically to protect the feedstuff against the microorganisms. So this technically to reduce the feed losses and to preserve the high value of the mixed feed. So Luprosils, basically in silage is to prevent the formations of the molds. And then this one will reduce the feed losses during the storage. Amacils basically is to reduce the pH level in the basic feed ingredients, the compound feed, and also the drinking water. This compound basically it will create a less favorable environment for the microorganisms, something like the salmonella and other gram-negative bacteria, which can be very harmful to the livestock. The last part of today is the new business model. Okay, the next one. Xarvio basically is the future of our farming. So basically, this is a digital farming solutions, which is offering the digital product that deliver the independent field zone specific ergonomic advice, enabling farmers to produce their crops at the most efficiently. So technically, this is also one of the applications that we use in Malaysia as well, on how to produce the highly yield rice in the northern part of Malaysia. So using Zario, so basically you have to have a better oversight, how to manage the risk related to your crops, and also how to increase the reliability in terms of the planning and the managing your crops and the field zones. The scouting, the field managers, and also the healthy fields product. So basically, these solutions is already used in more than 100 countries worldwide, including Malaysia. So I think that's it from me now, and thank you for withstanding long hours. I would like to have any questions if you have.
Uh, yes, but before that, a huge thanks to Mr. Petrus for the very insightful talk. I hope everyone's still here with us. Mr. Petrus, there are several questions in our pigeon box that maybe you would like to have a look at. Is that
How
okay?
to get? Yes, sure. But how to get there?
All right. Oh, oh wait. Sorry. Oh, waiting for the slide. Sorry.
All right.
All right.
Is the deal green technology can we describe? Okay, the first one is what is the deal green technology? Deal green technology. Oops.
All right. So the three questions for you, Mr. Petrus, regarding the talk is number one, what is the deal? What is the ideal green technology? What is the deal green technology that we can describe in effective leadership as one important element in industry? The second one is in our assignment, we were asked to include the pest analysis in our writing. Can you briefly describe what is the pest analysis and examples on how we can implement it in our daily lives? And finally, what is the deal between effective leadership on sustainability in industrial engineering and green manufacturing?
Okay, so I think I love to answer the first one in what is the ideal green technology can we describe in effective leadership as one important element in industry, right?
Yes.
Um, okay, so I think the first part I would say there is no ideal first because again, if you go if we go through the first three parts of our journey today, so basically we are looking is on what is our metrics basically what is we are looking for. I take examples from the mass balance approach. In some part of the world, especially in Europe, basically the mass balance approach actually is not considered as a green technology. Why? It's basically we are in the process. Basically, we are still producing the CO2 because the feedstock, basically the PET from the consumer, is already producing the CO2 before, right? Now, basically, we are balancing it back. So basically, here, basically, we are looking for what is the least evil in this case. So because as you know, the importance of the business, basically, we want to make the entry cost as low as possible. Because if the economic is, I mean, if the economic aspects is not viable, technically the business will not adopt for technology. I mean, this is the element that, I mean, it's a cruel reality, I would say. So in this case, what is the suitable for the chemical industry? Since we're already operating in this condition for a long, I mean, I can say for the past 100 years, is how to make a technology which is can complement with our current processes. At the same time, the entry cost is lower as low. I mean, it's as low as adaptable possible. So to answer that question, technically, in this case, there's no ideal. It's depending on what metrics you are setting for your projects. The second part, okay, this is actually is quite popular in especially in the business analysis, the PESELs, or they call it as the PES analysis. So PES analysis or PESEL analysis, or they call it as the PES analysis. So basically, it's a concept of the marketing principles. So usually this concept is a tool used by the company to track the environment that they're operating, or when they're planning to launch a new projects, product, etc. So PESTLs basically is the how to call it abbreviations. So P is for politics, E for economic, S for socials, T for technology, L for legal, and E for environments. So if you still remember, our first part is we are looking into the dimensions of the economics. We are looking into the dimensions of the socials, and also we are looking into the dimensions of the economic, socials, and environments. So basically, this is a give something like a broad view on how the different angle and how they want to keep something like check and balance of each other. So this is actually the principle that you can look into the triangle that I mentioned just now, if you still remember. When we are approaching toward the economics, so we are foregoing on the environments and we are foregoing on the socials. So what we try to look here, basically, we want to look for the middle, I mean, the common ground, which is in the middle of the triangle. So I hope I answered that question as well. And how to use it in the daily lives? Technically, is try to look what is the approach in the middle triangle. Okay. The next question is, what are the latest sustainable development goals and what are the steps to achieve them? How does leadership relates to achieving these goals? Okay. If you still remember from the United Nations, there are 17 SDGs they are mentioning too. So if you still remember my slides, the QR code from the very first page actually is to improve on the yield of the rice productions in Malaysia. So that projects, the target SDG basically is to eliminate hunger and poverty. So basically, this is actually one of, and of course, in order for them to ensure that the technology to improve the yield, of course, it must be viable. Again, it must go through the three triangle that I mentioned just now. For examples, like the GM is a genetic modified food, for examples. Some of the aspects, it will improve your yield of productions. However, some of the aspect from the social point of view, the people are reluctant to go for the GMO because it will ill adversely impact their health. For example, this is from the social point of view. And how the leadership relates to this achieving these goals. Of course, this is also important. I mean, if you go for the business 101, usually the approach of top down is more. I mean, it will drive faster. So this is the reason why large corporations like BSF, basically we are taking lead into taking lead in the sustainability topics, especially because once a big player like us playing a role, and subsequently the entire chain the entire chain, like the suppliers, like our consumers, also will be appeal or being driven toward that sustainability goals. So I believe this is where the leaderships, I mean, those who lead the markets, it can be the corporations like us, it can be from the political reforms, for example. So once it's coming and it becomes appeal to the people, then only they become sustainable. becomes viable. Okay, the next questions, if you can scroll it up. Okay, so what is the deal between effective leaderships or sustainability in the industry? Oh, okay. First, I would like to assume, okay, this is my assumptions. So basically, you're looking for the correlationship between the leaderships on the sustainability and how this one can break into the green manufacturing. I hope my assumptions is right. So I will answer from that point of view. So again, to drive a transformational change, it must always effectively driven if it's from top to bottom. I mean, at most case, this is true. So how to deal with the okay, for example, like in the industrial engineerings, especially on the chemicals, we are already operating in that processes for many years, because the goal of the chemical engineering, basically we want to look for the highest yield possible in the simplest process possible. I mean, in the layman term at least. However, while achieving that specific goal, we are foregoing the other aspects like the environment effects and also on the social impacts of what will be the consequence. I take examples from the most popular case in Malaysia, like the rare earth producing plant in Quebec, for example. The the people's sentiments basically, okay, this plant is dangerous because it can adversely impact their health. I mean, this is the the market, I mean the people's perceptions. This is where the leaderships of the corporations, they are taking it to ensure that their process is less or at least less impact as possible into the peoples and also into the environments. And in fact, actually, this is also one of our goals. Also, we want to ensure that our production plants, our peoples, is always minimize the impact to the environment and also the society as a whole. So this is important, whereas because we are considered as the leader of with the leader of the markets, whereas once we bring that approach, then the subsequent impact will be on our suppliers, our contractors, and also our workers, which is directly dealing with us. So this is actually why a big corporations basically can make a big impacts on this. I hope I answered it correctly, or at least touch a little bit on the intake. Any more questions, maybe from the floor?
I am very sorry, Mr. Petrus, but I think due to the shortage of our time, um, these are the only questions that will be asked by the participants as of now.
Mm.
So that marks the end of our event. We hope each and every one of you. Oh, sorry. Thank you again so much, Mr. Petrus, for your valuable information and your even more valuable talk. Now that marks the end of our event. We hope each and every one of you have gained valuable insights and found the talk enjoyable. On behalf of our team, we extend our sincere gratitude and thanks to each and every one of you who is here today, especially our distinguished guests and our participants. We look forward to seeing you at our next event. A little reminder to all the participants, please fill out the feedback form provided in the comment section or by scanning the QR code. Before that, there will be a short photography session with us all together. It would be lovely and much appreciated if you could give cooperation to be a part of the snaps, which later are to be kept as the memento of this event. I will now hand this photography session to the multimedia department.
Hello everyone, I am the person in charge for this photography session. So before that, can everyone open your camera and use the virtual background that have given in the group WhatsApp.
I hope my cameras work. Yeah, I'm not sure whether it's on or not.
Perfect, sir.
It's perfect. Oh, great.
Perfect.
So are you guys ready?
Yeah, I guess so.
Okay. So, okay. Format. 1, 2, 3. Okay. Lagi sekali. 1, 2, 3. Freestyle. 1, 2, 3. Alright.
Thank you so
That's
much, Elizatul. And thank you everybody else for your cooperation. Well, with that, thank you so much again, Mr. Petrus Simon. We hope to be able to keep in touch with you and later on meet you in the industry ourselves. Once
Yeah,
again,
sure.
a
I mean,
thousand thank yous. Oh, sorry. Once
yeah,
again, a
I
thousand
mean,
thank yous. Oh,
if you have any questions, yeah, feel free to drop me an email and so on. Yeah, I would love to answer these kind of questions. And in fact, actually, this is the approach from our organizations. We are looking for more awareness on the sustainability, especially topics now, which is on the, I mean, the hotline. And thanks for having me today. Yeah, I really enjoy it. Thanks.
well, thank you again, Mr. Petrus. And with that, until we meet again, thank you. Assalamualaikum warahmatullahi wabarakatuh. Stay safe, everybody, and have a wonderful day ahead. Oh, and don't forget to scan the QR code for the feedback form if you guys haven't. Comment section.
Thank you, sir.
Thank you, sir.